This video is about percent yield. The concept of percent yield, if we just look at the word yield, yield means to make something. Don't think about yield in driving. Think about yield in, let's say, farming. Okay, so when we say yield, we mean how much product you can make. And so everything that we have been calculating before is called theoretical yield. Everything that we have been calculating before assumes that when you use all the reactants in the reaction, and the reaction goes all the way, how much product can you make? And that is also the maximum amount of product that can be possibly made using all the reactants. In reality, we often don't reach that maximum. So what do I mean by reality? If you do the reaction in a lab, or you carry out the experiment, you often don't make that maximum amount of product. So everything that we calculated for is theoretical. So theoretically, you should be able to make this much. In reality, you don't. So I'm going to write those terms down. So theoretical yield is the maximum amount. An amount could be measured in moles or in grams, so mass, moles, or actual number of particles of product that can be made using the given amount of reactants. And that is the maximum. So this number often comes from calculations. Calculations using the limiting reagents. And then you have something else called actual yield. So now this number is the amount of product that's made in reality, that are made in reality. Reality meaning in a lab, in an experiment, so this number does not come from calculation. This number does not come from calculation. Not from. So this number can only be obtained if you do the lab itself. It's experimental. Okay. So the reason why we cannot, sorry to mention this, actual yield often does not match your theoretical yield. So, meaning the amount you make in a lab often doesn't match the maximum amount of product that you calculated for. And the reasons are, so reasons for not reaching this maximum amount, reasons why theoretical yield does not match, or I should really say the opposite. The reasons why actual yield does not match theoretical yield. So reasons why we cannot make the amount of product in an experiment that matches what we calculated for is due to the following couple of reasons. So one, maybe your reactants are impure. So we have impure reactants. So meaning maybe let's say this reaction requires the use of copper, and you put in 15 grams of it, and you think that all 15 grams are actually copper atoms, but maybe out of the 15 grams, some of them are not copper. Two, you might have competing reactions. So you think that this reaction is supposed to all go on and make the product you want, but maybe there's a side reaction that's going on that's making something else that you don't want, but it's using up your reactant. So now, out of the amount of, let's say again, 15 grams of copper that you have, not all of them went to make the product that you want. Three, maybe your reaction requires certain conditions. So by conditions I mean maybe your reaction requires a certain temperature, a certain pressure, a certain concentration, but maybe in your lab you haven't satisfied those conditions. And the fourth reason could be that simply your reaction didn't go all the way. Reaction did not reach completion. So these two reasons relate, because if you don't have ideal conditions, then the reaction is not going to go all the way. And it has to do with a grade 12 concept called equilibrium, where up to a point, even though your reactants are not all used up, your limiting reagents are not all used up, the reactions stops. Not that they stop at the molecular level, it's just that it's kind of like a tug-of-war, where the reaction will go both ways, and overall, you have stopped making more product. So let's look at an example. Marble is primarily made from calcium carbonate. When calcium carbonate reacts with hydrogen chloride, it reacts to form calcium chloride, carbon dioxide, and water. If this reaction occurs with 81.5% yield, what mass of carbon dioxide will be collected if 15.7 grams of calcium carbonate reacts with 10 grams of hydrogen chloride? So lots of wording, but let's pick out the reaction itself. It says when calcium carbonate reacts with hydrogen chloride. Calcium carbonate is ionic, so we crisscross to get the formula, and you should get CaCl2. Reacts with hydrogen chloride. Hydrogen chloride, you may be wondering why we don't call it hydrochloric acid, and it's just saying that it hasn't been dissolved in water yet, so it hasn't become an acid. Formula looks the same though. It reacts to form calcium chloride, carbon dioxide, and water. This reaction is not balanced, and in order for us to do correct stoichiometry calculations, we must balance the equation. Looking at this, I think a 2 here will do. And then it goes on, so we got our product. It goes on to say, if the reaction occurs with 81.5% yield, what mass of carbon dioxide would be formed if 15.7 grams of calcium chloride reacts with 10.0 grams of water? So just like before, we'll set up our chart: mass, molar mass, moles. So again, we are looking at the amount of product that's being formed. And you're given two quantities of reactants. And whenever you're given two quantities of reactant, you have to figure out which one you'll run out first, because that determines the maximum amount of product that could be formed. Or that determines the amount of product that you can make. So we have to go this way, and we should also go this way. We divide by the molar mass. The molar mass of calcium chloride is 100. Oh, I just realized I wrote the formula wrong. Calcium carbonate, not calcium chloride. Calcium carbonate. Now the reaction is balanced. So the molar mass of calcium carbonate is 100.078 grams per mole. The molar mass of hydrogen chloride is 36.453 grams per mole. And so the amount of moles of calcium carbonate we have is 0.1569. So I'll leave more decimal places. 0.1569 moles of calcium carbonate available, and the amount of hydrogen chloride is 0.2743 moles of hydrogen chloride available. I'll draw this again. 0.2743 moles of hydrogen chloride available. And now arrows go down and across, down and across. The mole ratios are 1 to 2 for carbon dioxide to hydrogen chloride, and the mole ratio for carbon dioxide to calcium carbonate is 1 to 1. So this tells us that with the amount of calcium carbonate we have, we will make 0.1569 moles of carbon dioxide, and with the amount of hydrogen carbonate that we have, we will make 0.1372 moles of carbon dioxide. So we take the smaller amount. So don't confuse this with when I say the maximum amount of product that could be formed. When I say the maximum amount of product that can be formed in a reaction, I mean the maximum of product that can be formed from the limiting reagents. So remember that even though the calcium carbonate allows us to form 0.1569 moles of carbon dioxide, this cannot actually happen because hydrogen chloride would have run out before then. So considering both reactants, the maximum amount of product that both reactants allow us to form is actually only 0.1372, the lesser amount. that happens when this run out. So this is the maximum amount of product that we can form with our reactants at the point that they run out. And if we convert this to mass, now that we know that 0.1372 moles of carbon dioxide can be formed, we can now go and calculate the mass of that. So mass of calcium carbonate that could be formed is 0.1372 moles times the molar mass of carbon dioxide is 44 grams per mole equals 6.04 grams. This is our theoretical yield. This is our theoretical yield because, one, we calculated this using the amount of reactants, and two, if you think about this number definitely didn't come from doing a lab or doing this reaction in an experiment. And remember I said that this is the maximum amount of product that could be formed using our limiting reagent. So this is our theoretical yield. But then the question tells you that in an actual lab, the yield is 81%, which actually is pretty good. So meaning that out of what you calculated for, in reality, you can only make 81.5% of that. The equation for percent yield is actual yield divided by theoretical yield times 100%. So when would percent yield be 100? Percent yield can only be 100 if these two numbers are the same. So for example, if you calculate that 2 grams of product can be made, and you actually made that, 2 divided by 2 is 1. The number 1 as a percentage is 100%. So 100% yield means that you have actually made whatever is possible in a reaction. And that rarely happens. And in this reaction, they told us that, 1, you cannot make everything that you calculated for that's possible, that you think is possible given the amount of reactants. 2, in fact, you can only make 85% of it. So we can do 81.5%. I'm going to use the letters A over T. Our theoretical yield was 6.04 grams times 100%. And by the next step, by changing this to a decimal, we have gotten rid of the 100% at the end. So this accounts for changing these two here, accounts for changing the number into a decimal. Equals A over 6.04 grams. So actual yield equals, if we isolate this variable, we have to multiply 6 over to the other side. 0.814 times 6.04 grams, that equals, and I have no idea why I wrote 814. I should be writing 815. 0.815. 4.92 grams. So therefore, 4.92 grams of carbon dioxide can be collected when you actually do the experiment. Even though what our calculations shows that we should be able to collect 6.04 grams, in reality we couldn't. Okay. So again, a review of what we did. Step 1, write the balanced chemical equation, and don't write it wrong like I did, and don't balance it wrong. Otherwise, all your math, your ratios would be wrong, and everything else would be wrong. So step 1, write the balanced chemical equation. Step 2, determine which one the limiting reagent is. So this, I should really have written this. This is our limiting. So step 2, determine which the limiting reagent is. Use the limiting reagents to determine the amount of product that could be formed, which also is the theoretical yield. After we determine the theoretical yield, we can now use the theoretical yield with the percentage they gave us and say that we can only make 81.5% of this theoretical yield, 6.04 grams. So in reality, the actual yield made in a lab or made from an experiment is 4.92 grams. So that's what we did. Or you can think of it this way. You can think of it as we can only make 81.5% of your theoretical yield. And when we change that sentence into math, 0.815 is equal to 81.5% of. The word of in math means to multiply. So, in other words, 81.5% of 6.04 grams is how much we can actually make, which is equal to 4.92 grams. We're going to go on and do part B of this question in the next video.